use many different types of pumps. One of the most common types of pumps that plants depend on is a centrifugal pump. Centrifugal pumps use centrifugal force to move process liquids. One basic requirement that affects the operation of all centrifugal pumps, large or small, is that they must be primed. In other words, the pump casing and suction line must be completely filled with liquid before the pump is started. If a centrifugal pump isn't primed, it won't operate properly. Now, some centrifugal pumps stay filled with liquid when they're shut down. These pumps are often called self-priming pumps. A common way to prime a centrifugal pump is to open the pump suction valve and the vent valve. Opening these valves allows liquid to fill the pump and air to escape. In order for this to work, however, either the level of liquid to be pumped must be higher than the casing of the pump, or the suction pressure must be great enough to force the liquid into the pump. If the pump is handling a hazardous liquid, the casing vent should be piped to equipment that will prevent the escape of hazardous liquids. If the liquid level is below the pump casing or the suction pressure is too low, a variety of devices can be used to prime the pump. On most pumps, the point where the pump shaft leaves the casing is a place where leakage can occur. To prevent process liquid from being lost or contaminated, either packing or a mechanical seal is often used to seal this area. When packing is used, operators should check to make sure that there is a small amount of leak-off to lubricate and cool the packing. If there's too little leak-off, the packing can dry out and burn. If the packing dries out, the pump should be shut down so that the packing can be replaced. On the other hand, if there's too much leak-off, the efficiency of the pump may be affected. To control the leak-off, the packing must be tightened. This should be done by tightening the nuts on the packing gland one flat at a time. For example, during startups, the casing and suction piping may have to be vented. If a sufficient amount of air remains trapped, the pump will not operate properly. Another way that air can get into the casing is through a leak. The suction of a centrifugal pump is normally at a low pressure, and this low pressure could draw air into the pump through leaks or the packing. On some pumps, the packing is exposed to the same low pressure that exists at the pump suction. On these pumps, the packing is often supplied with liquid from the discharge of the pump. This liquid cools and helps seal the packing. If the flow of liquid to the packing is not adequate, air could be drawn in through the packing.
Side, we've got a cross section. Now, I'm not going to go through the terminology and the components because we've covered that in another video, but let's just go through the components that we actually need to talk about. And the components are the impeller and the volute casing. So how is it that the centrifugal pump works? You can see from the design and the animation that the pump's construction is quite simple. Essentially, we've got an impeller rotating within a volute casing, and as it rotates through the liquid, we're creating pressure, and this pressure differential, that is the difference between the suction side of the pump and the discharge side of the pump, is what causes the liquid to flow. Well, in order to understand how the centrifugal pump works, we need to have a very quick look at some of the theory. So let's first pull up an open centrifugal pump impeller. So here we are, we're now looking at a centrifugal semi-open type impeller. So the type we saw earlier was the enclosed type, and this one is a semi-open type or the semi-closed, depending on how you want to look at it. As you can see, it is rotating in a clockwise direction. I'll give it a little spin. And we can see also that there's a shaft in the middle of the impeller and a shaft key which connects the shaft to the impeller itself. The suction side of the impeller is this middle area here. That's what we call the eye of the impeller. And as we draw the liquid in, we're going to create a negative pressure at the eye of the impeller, and then we're going to throw the liquid outwards radially away from the center of the impeller towards the outer periphery of the impeller. The reason the liquid is thrown outwards radially away from the center eye of the impeller is because of the friction between the impeller and the liquid. As the impeller moves, some of this movement is imparted onto the liquid, and because the impeller is rotating from a center axis, the liquid has a tendency to be thrown outwards away from the eye of the impeller. Now the force that causes this is known as centrifugal force, and because this type of pump uses centrifugal force, it's called a centrifugal pump. If you've ever driven around a corner very fast in your car, you'll know that if you're driving around a corner and turning into the left, you have a tendency to be thrown outwards to the right, and this is centrifugal force. Now the impeller does the same job, although on a much smaller scale. It rotates very fast from a center axis of rotation, and the liquid that is drawn into the center is thrown outwards to the side, radially away from the eye of the impeller. This centrifugal force gives us a large increase in velocity, which we can later turn into pressure. So let's just pause the animation and I can show you the flow path of the liquid. So the animation is now paused. Zoom in. Our liquid would come in fact, let's just do it as the liquid would flow. We would flow into the middle like so. The liquid is then thrown outwards radially, and it's going to go between these two veins, or between a set of veins I should say, between a pair of veins, and then it's going to flow up along here. It's going to be thrown outwards, and then it's going to leave the impeller. So let's do it this time, but this time we'll just add some arrows to mark the flow. So as you can see, now the liquid would flow out radially, and as it does so, as it flows out through the channels, the flow path area is going to gradually increase, or a diffuser, but the concept behind the design of the volute casing and diffuser is the same as for the impeller. We know that we need to increase the flow path area in order to increase the pressure. And as you can see on the diagram now, the volute casing does just that. As the liquid is discharged from the impeller, it's going to flow around the volute casing, and we're going to get a reduction in velocity and an increase in pressure. And that is essentially how a centrifugal pump works. There really is nothing more.
Thank you very much for watching. Please like and subscribe the channel. Let's make machines simple. Share MMS to friends and family members.